on this computer, share screen. We're going to share the Python shell to begin with. All right, to review, what is a dictionary? A dictionary is an extremely valuable tool. You create a new dictionary by using other curly brace notation, as opposed to a list, which would use the brackets. Okay. You don't need to follow along. I'm just trying to remind everybody the way dictionaries work. You can populate dictionaries so that basic with certain key value pairs. So for instance, we might say in this assignment, we'll be basically looking at the fact that like the Roman numeral X is equal to 10. So we can look up our dictionary and say, hey, what is the what is X? What is the translation of the Roman numeral X? Sorry, was the translation of the Roman numeral X? And because we've defined it in our dictionary, it will tell us that it is 10. So a dictionary basically is a list. It resembles a list superficially, but it has significant differences. The first of which is, the most important of which is that basically that it doesn't use indices. It uses user-defined keys. So if I ask for what 0 is, what the key, what corresponds with 0, if I haven't defined it, then it won't tell me what it is. But as soon as I define it, it gives me an answer. Right. So dictionaries essentially they act like lists and they use the same notation, but they operate in a very different context. Dictionaries work by looking at by using key values things and key value pairings. Now almost anything can be a key and almost anything can be a value. Well, sorry, almost anything can be a key and anything can be a value. There is no, so the big thing about lists is that lists imply certain things. Most specifically, lists imply a structure and an order, right? So in a list, there is an ordering. There's the first item, second item, third item. There is no such order in a dictionary. So append doesn't really have, an append means add to the end of a list. So since there's not an end, right. But functionally, no. If you want to add something to a dictionary, you just simply say, hey, this is the key value pairing. Now, if the key value pairing already exists and you put, if you put something else in, so I put in 0, the key 0 is mapped to something, and I want to say it's now something else, quite literally. Notice there's not an error here. What happens is is that it just simply updates it and overwrites it. It is possible. This is super rare. This is probably the only time you're going to see it in this class. It's super rare, but if you wanted to remove something from a dictionary, you use del and then it's weird. You just simply go space and then D. Like, I think this is how it works. And the fact that I don't know how to work, it is, there we go. And now the binding for X has been deleted from the dictionary. This is super rare, not very used. Yeah, just like a list, this is mutable, so you can change it. In fact, it needs to be mutable so we can create new bindings. Right. So what we're going to be doing today is using dictionaries to do, so you're going to want to go onto Runestone and go to project 13, which is converting Roman numerals. Okay, so I'll give everybody a second to pull that up. That's our in-class exercise for the day. So I took this, so this is not me, but the author says, I took this picture on the island of Gozo at the citable city of Vitorija. Anyway, it says island is a small island that's part of the country of Malta, which is a very, very tiny country. It's been conquered by just about everybody at one point or another in the history, including the Romans. And they presumably gave us Roman numerals, and we can see these Roman numerals up here. But there's a problem with this arch, which is that the Roman numeral up here, MD, CC, CC, IV, is not correct according to the rules for proper Roman numerals. So specifically, this is trying to spell out 1904. So I don't know how many of you, so wasn't too familiar with the rules for Roman numerals, and I'm sure there's plenty of us who don't know all the rules for Roman numerals. So let's go ahead and talk about what the rules for Roman numerals are. Repeating a numeral. So Roman numerals are basically, they used letters instead. So they used I, V, X, and L, and C, and D, and other things. So they didn't use the handy dandy base 10 system we did. They had a really weird number system. So rules: repeating a numeral up to 3 times, it represents adding a number. So one common one is by doing I, which is 1 plus 1 plus 1, which is 3. Make sense? So if you see a single I, that's 1. If you see 2 I's, that's 2. If you see 3 I's, that's 3. If you see I, that's not 4, it's wrong. They're trying to write 4, but it's wrong. So only I, X, C, and M can be repeated. So I in this case is, that's 1, X is 10, C is 100, and M is 1000. Everybody got that so far? Right, those are our base 10 numbers, or those are our powers of 10. Additionally, we also have numbers called the numbers V, L, and D, which are 5, 50, and 500 respectively. Okay. So you don't repeat these 5 numbers, because there's no reason. VV, which is 5 plus 5, would just simply be, X, which is 10. LL, which is 50 and 50, that's 100. Makes sense? So 1, 10, 100, 1,000. And then we've got 5, 50, and 500. So writing numbers that decrease in values from left to right represents addition. So for example, MC is 1100. That's 1000 plus 100. And XVI is 10 plus 5 plus 1, so 16. Make sense so far? So it's fairly straightforward. If the numbers are in descending order, you just simply add them up. However, to get numbers like 4 or 7, to get numbers like 4 or 9, you got to use a negation rule, which is that writing a smaller number to the left of a larger number causes the sign of the number on the left to be negative. So IV, that's 4. It would be -1 plus 5, or it's 1 before 5. So MCM XIV is 1000. Then CM is -100 is 900. That's the way I look at it, but they go, it's -100, 1000, and then X is 10, IV. Now, because we have a number out of order, IMV, it becomes -1 plus 5. This is the way they write 1914. And it's this 4th rule which really makes it a real pain in the butt. So now you know all that. Now that you know these rules, let's go ahead and try on your own to write the correct Roman numeral for 1904, which they wrote as MDCCCC IV. So try to write that in the correct Roman way. And once you're done with that, do the matching problem over here so that because we want to make sure you can convert that you're fairly comfortable in converting these numbers. In a couple minutes, I'll ask if people need more time on this. All right. So do people need more time on this one? All right. So let's go ahead and so for Roman numeral 1904, M is 1,000. So now we need 900. 900 is 1 before 1,000, so CM. So this is negative 100, 1,000. So that's 900 over there. 0, we don't need to do anything. And 4 is IV. So let's check it. That's the correct answer. Cool. So now we've got this. So MCD. I guess that would be what? MCD, what is D again? D is 500. So 100 before, so that should be that. That's 100 before 500, right? So that's cool. 1,999, that should be fairly easy to figure out because that's 1. So that's 1,000, 1 before 1,000, 10 before, sorry, 1,000, 100 before 1,000, 10 before 100, 1 before 10. And then same thing over here, except it ends with an 8, right? This, how did I see this one so quickly? I just looked for the one that ended with an 8. VII, that ends with an 8. So this should be 1,000, 1,000. So 2,000 CCC, which is 300. then XL, which is negative. So that would be 1050. So since it's 10 and 50, then 10 becomes negative. So XL is 45. And process of elimination does say this, but right, you've got 1,549. Everybody follow that?
She made a sad meow and left. She didn't like
Okay. So now let's talk about converting Roman numerals to Arabic, right? Which is figuring out what these are and converting it to their standard Arabic base 10 numerals, right? Which are honestly a lot easier to work with. Roman had benefits in the sense that it was fairly short and concise. However, it's really only advantageous when you compare it to something like base 1, which is just simply making check marks. Okay. So now that you're an expert in converting Roman numerals to numbers, it's time to save ourselves the trouble and write the program that does it for us. So first thing we want to do is ask the user for a Roman numeral. Validate the number to make sure it follows all the rules. The number in the picture should create an error message. And then if the Roman numeral is valid, we convert it to the Arabic equivalent. Then print out what was input and what the Arabic equivalent is. And obviously, the other way around we're going to do things is converting Arabic to Roman, right? So after that, so what we're going to want to do here is, it says hint, you want to first start by creating a dictionary to map each single character, Roman numeral to the correct Arabic number. So we can create a dictionary, and this is what I'm going to start you off with. And we can populate it in one of a couple ways. We can say, hey, if we see an X, right? Sorry, DX, then we should register that as a 10, right? We're converting from Roman to Arabic, right? So we can, and we're just going to work with single characters right now. So we could do that for all of our characters. So like go through and say, okay, then I is 1, X is 10, and create all the entries for that. That's the first thing we'd want to do. Another way we can do that is do that directly in here and say I 1, comma, X 10, right? And it has no issues with that. In fact, if I say print DI, okay, then we will run it. Now this one is not the one where I'm going to tell you to take 5 minutes and do this, because you can't do this one in 5 minutes. It's actually a bit of a pesky one. So you'll want to go ahead and populate this dictionary as your first thing. Next, you want to validate that the number to make sure it follows all the rules. Okay, so maybe do that as a function. And then third, if the Roman numeral is valid, we should then convert it to its Arabic equivalent. Okay, and again, what we're going to want to do is kind of verify. We can make the verification more and more advanced as we need, but for right now, you should make sure that there's only a certain number of each of these characters. Okay, now if the Roman numeral is valid, we should convert it to its Arabic equivalent. So we should create two functions, which I will just simply put here: def valid Roman, which will default to returning true. It's easier to prove because it's easier to prove that it's not valid. Right, and so we're going to go ahead and assume it's true. Def convert which it will basically take a a valid, and we can assume we can assume that's a valid Roman number. I'm just going to return -1, which is obviously wrong, but for right now, it gets everything to compile, which is great, right? So those are the kind of things we'll need to work on. This asking the user for a Roman numeral. So part 1 and part 4, we can just tack that on the end when we're done. So let's start by doing this, and then we'll check. So fill up your dictionary if you haven't already. Share the code. Fill up your dictionary if you haven't already, and then check back in, and we'll go ahead and do that. All right, so let's go ahead and do this for the people who haven't done it yet. Okay, so Annie. Just very distracting. Oh, I did not hear that he was listening. So we now need V, L, and D.
And Roman numeral units.
V, 5, L, and D. D is equal to swear I've programmed before. 50, 500. So there's our dictionary that we needed. Okay, so now to validate the Roman numeral, right? That's first we got to make sure it follows all these 4 rules, which is that you can repeat a numeral up to 3 times, and only MIX and IXCM can be repeated. V, L, and D should not be repeated at all. So let's go ahead and create ourselves some strings, which are let's call it digits right over here. Digits is equal to IXCM VLD, right? Those are all the keys here. So first off, let's make sure that that only Roman numerals are in here. 4 letter in Roman. So for each of the letters in the Roman numerals, right? What are we going to do? We should we should go and say, hey, if letter not in digits, return false, which would just stop the loop right there and stop and basically immediately say it's wrong. Because, hey, if we've got something that goes MXCA 7, that's obviously not a Roman numeral, and we should return false for a couple different reasons. Okay. So next, our next thing we want to do is making sure only I, X, C, and M can be repeated, and they can only be repeated up to 4 times, or up to 3 times, right? V, L, and D should not be repeated. So we'll make use of the count, right? So Roman.count, right? We can do something like, just to kind of show this off, because I'll have you do that. If I have, so if I do banana dot, sorry. If word equals banana, word dot count, let's go ahead and count the number of A's that appear in this, 3. So what you're going to want to do is count to, the number of letters, count each of these letters that appear in the Roman numeral, and make sure they are no more than 3. You know, there's less than or equal to 3 I, less than 3 equal to X, less than 3 equal to C, M's, and only one, and at most one of V, L, and D's. So go ahead and program that part into the valid Roman part. All right. So for this one, I'm going to go and say for each of the possible digits that we have, because they're conveniently written out here at the top. For each of these, let's see. Well, actually, I can't say. I want to make sure they know they don't appear more than 3 times. So actually, let's go ahead and say for digit in these guys. If Roman dot count that digit is greater than or equal to, is greater than 3. If we have more than 3 of those, then return false. Similarly, let's go ahead and copy and paste this. And for VLD, if it's greater than one of these, return false, because you can only have one of those, right? Actually, not true, I don't think. You can have, now let's think about this for a moment, actually. Because it's just saying that you can't have repeats of more than these. Right? Because you always got to check your assumptions, right? Yeah, that was exactly what I was thinking, Nicholas. Right? XXXIX would be valid, right? 39. 39 is XXXIX is valid. So thinking about this now, right? Part of the reason I like this one is because you can go on to an assumption, but you got to make it, but you always got to double check your assumptions here, because I made an assumption, it was wrong. So this would be wrong. So really what we're looking for is repeats, right? So let's look for repeats. So 4-digit in IX, so still looking at this. If let's instead change the question we ask. If digit times 3 in Roman, sorry, if digit times 4 in Roman, right? So again, let's open up idle, right? Word is equal to XXXIX, right? We can ask, is XX in word? And it will say true, because you've got this over here is XX, this over here is XX, right? If we can ask if IX in word. And then, but if we ask if we've got 4 in a row, which would be one more than 3, be false. So what we're asking, Kay, is there 4 in Roman? And that would also catch 5 and 6 and 7 being repeated. Right, because in order to have 5, you would have to have 4. In order to have 6, you would also have to have 4. So if that's in there, return false. It's a hacky way to do it, but I like it. So what should we change this to? Right, not digit times 4, but digit times what?
1.
1, well, 1 would be digit, right? Should be 2, because we want to see there's more than 1. Exactly. So now we can check. So now that would work for those. So that beats this rule over here. So there's no repetitions that should be ignored. So now writing numbers that decrease in values from left to right represent addition. So now the thing is that it's like it only wants us to do let's see, we would only want to make sure that an X, we could probably go through more cases, like to make sure that so with things coming before other numbers, right? You can do I before V, right? And that gives us 4, right? Likewise, we could do I before X, and that gives us 9, right? But doing something like that doesn't work, right? Nor does doing IL, which would be 49 and writing it like that. 49 would be, let's see, what would 49 be? It would be 3x's. It would be actually XL, right? We've got 40, and then IX would be 9. So I'm guessing that what we would want to do is basically, I would probably want a pretty big statement, like saying, what I could do later with something like invalid. So I could do something like over here on top, invalid combo. Oh, sorry, invalid pairs. I could do something like this. Invalid pairs is equal to, and just make a list of strings. So like having VX and having a list of stuff that just shouldn't appear. That would take a while, but that's one way to do it. So I'm going to leave off on making sure that everything is in the right order for right now. Okay, makes sense. I'm going to leave this rules 3 and 4 off for right now. For right now, for our validation function, I think that's fine. We'll tackle it again when we hit edge cases, if we hit edge cases, right? Makes sense to me. It makes sense to everybody else. We're just gonna make sure that this is, we're gonna make sure that this works as it is before we go on. You know, we know this works for the first 2 cases, and maybe we'll think of something else as we're working. So now, how do we convert from the, so now assuming that we've got a correct Roman numeral, correct Roman number, how do we go about converting it? Well, pretty much what you do, with one significant exception, right, on rule 4, is that we just simply go through and we go and add everything up. So go ahead and work on writing code that just simply says, for each digit, let's create a running sum and add all the digits of this up. It's not going to give you the correct answer for this, right? It's not going to give you the correct answer for this. It will probably, right now, with what I'm asking you to work on, I want this to be equal to 41, when in reality that should be equal to 49, right? Or sorry, that should be equal to 39. So that should be equal to 39. But what I'm asking you to do, if I'm asking you to add everything up, saying, oh, that's a X, so that's a 10, that's a 10, that's a 10, that's a 1, that's a 10, right? Work on that first. Let's just do that first pass, get an answer, even if it's incorrect. Then from there, we can work on and try to think about it, because this gives us the basis of trying to figure out how to do that. So go ahead and work on that.
I think you're muted, Professor.
I am totally muted. Okay, so first off, it should be convert rather than covert. So what we're going to do is we're going to do a running sum. And again, we're doing this addition incorrectly, but it's a good first step. So we're going to say digit total. So for digit in Roman, return total, right? So what we're going to do is that we are going to simply say, hey, for every single digit, right, we are going to convert it into the Roman equivalent. We're going to take that Roman digit and turn it into the Arabic equivalent. So total is equal to D and give it the key of the Roman digit. So right now, in the case of like our test case, which is 39, which again will add up to 41 in this case, it'll take it's going to get an X. It's going to get the first X, which will be 10, the second X, which will be another 10, third X, which will be another 10 for a total of 30. Then we'll get the I, and then the fourth X, which will be a total of 41, right? So if I say to print convert.
So your mic cut off.
So if I say to print convert this number. What the?
Yeah, addition.
Right. There's no addition. So I need to increment actually. So we get 41. Okay. So now, now we need to fix this. We need to allow the negation rule, which is to write a number that would otherwise take a repeating of 4 more times. There's a negation rule. Writing a smaller number to the left of a larger number causes the sign of the number to be negative. So what we have to do is essentially for every number, we need to look to the right. We need to, for every number, we're going to look to the left. Sorry, we're going to look to the right. So we're going to look one ahead and see, hey, is this number bigger than this number? If the number to the right of me is bigger than me, then I need to be negative, right? So again, for XXXIX, since 1 comes before 9, we're asking, sorry, for 1, since 1 becomes before 10, we're going to, since 1 is less than 10, we're asking for the number that's 1 less than 10. So this is going to require a bit of just kind of foresight here, right? The biggest issue is looking one ahead on this number, right? Is that I'd get it out of bounds, right? If I try to look for the, if I try to compare this guy to the one to the right of him, I'll get it out of bounds. Make sense to everybody? That if that trying to look one to the right over here will give me an out of bounds error. So we're just going to go and quietly kind of ignore that and say, hey, we're just going to do everything from, we're going to slice. We're going to just do all the numbers except the last one, right? Let's add up all the numbers except the last one, right? And furthermore, let's go ahead and enumerate that so that we can figure out our indexes. Enumerate. I like enumerate because, again, it gives me the ability to go through the index and the digit. So it's saying XXX. And we can go ahead and actually do one more and say, we can print the value that corresponds with it, right? So we've got 10, 10, 10, 1, and that'd be 31. Now, we also know that since the last number has nothing to the right of it, it's always going to be positive, right? The last number is always going to be positive no matter what. So return, then so we can say total is equal to total. So we can say last digit is equal to Roman -1. Does everybody understand why I'm doing this? Is everybody able to hear me?
Yeah, I can hear you.
Okay. So the last digit is equal to Roman -1. And so we can add in that last digit and say total is equal to total plus D. And so now all we have to do is look one ahead. And if it's one ahead, if the guy one ahead of me is bigger than me, then I should be negative. So let's copy this over, which is completely unnecessary, but I'm going to do it anyway. Share. So go ahead, and I've shared this with you. You'll want to complete the code so that this will correctly, you have everything that you need now to modify this for loop. So now it will print out. So now that the index 3 will register as -1. So go ahead and fix that, and try, and I'll give you a minute or so to try to change that to -1. It shouldn't be too hard with all the prodding I've been giving you. Okay, so the last part we need to do. So we need to look ahead. So that's why we have the index here. So we're going to go ahead and basically say we need an if statement. So first off, if, let's go ahead and basically say, let's go ahead and create something called modifier is equal to 1. What I'm going to do is I'm going to go ahead and multiply this. That way I don't have to redo code. I'm being a bit clever here. Unnecessarily clever. And what I can do now is I'll ask a question, and if we need to subtract, I'll just flip modifier to -1 rather than trying to write total minus. So if D digit is less than D, and so now we need to get the value, the letter that's one after us. So that would be at the location index +1, except that doesn't give us that's a number, not a key. We need the thing that is there. So Roman index +1. So it does look a little messy, which we can modify a bit out. Let's go ahead and say next digit is equal to, so always simplify if possible. Right. It's always best to make it readable, even though what I had previously before I just cut and paste was correct. So D next digit. So if this digit is less than the next digit, then that's our flip condition. So we're going to say modifier is equal to -1, and that should do it for us. Right. There are ways to make this a bit longer, but I try to balance conciseness and the ability to read it. So shoop. I said shoop. Okay, run. So we got 10, 10, 10, -1, and 10. So that gives us 39. So for the most part, I think we're done with this. Okay, so we can take an arbitrary Roman number. All right, let's go ahead and so MC MXC 8. MC MXC VIII should give us 1998. So there we go. So there's our completed code for this exercise. I will share the code. Okay, now let's talk about converting Arabic to Roman numerals, the opposite direction, which is a bit trickier, but it gives you a pretty good way to do that. So now there is a bit of a tricky thing where they created their dictionary like this, ordered dictionary. So because of the browser limitations, we never called validation because I don't think we really need to, I don't really need to test it. We can test it on this particular string, but it will actually not work on that particular string because it will not check. We didn't really finish validation because, and it's not really testing validation, but it's already an hour into the class, so we have 20 minutes. So I want to move on to the converting Arabic to Roman. The validation's actually, at this point, validation is more tricky, is more annoying than anything else. So anyway, I want to work on converting Arabic to Roman at this point. Can you write a program that goes in the opposite direction? Given an Arabic number, can you convert it to a Roman numeral? So the difference here is that rather than using a dictionary like I did, it's using something called an ordered dictionary, which means that it will iterate through it in order. So like, for instance, if I go for key in Roman, print key, I'm going to just actually call it K because it doesn't have to be called key or anything. But if you do it like this, you're going to get the key. And you get 1,950, 400, 100, and 1. And when you specify it in the ordered dictionary, when you specify it like this, it will go through in the order that everything is presented. So if I swap this around and said, hey, this guy maybe should go first, which is wrong. But if I did that first, we'll get that. So that's why that's why it's using an ordered dictionary. Now, this is the default behavior for Python if you're above 3.6, but because of the way the browser works, it's not the default way. So they have to use the ordered dictionary for that. So anyway, what you want to do is essentially go through. So how would we do this? How would we I think it would, I'm not really sure how it works with the with this, but with our dictionary over here, with the dictionary over here. So first off, in other programming, the reason I don't know this is because, as you know, Dalvir, in 2168, when I talk about hash maps and Java and hash tables specifically, I talk about how there's no guarantee of order, right? And so I don't specifically know in Python because this seems to be a recent change, a fairly recent change to the Python programming language. So if I said D S is equal to 1. Okay, sorry. D is equal to this. D S equals 1. D A equals 1. I'm just putting 1 because whatever. D1 is equal to 1. Right? We see that it's maintaining the order in which you put things in. And then for K in D print K, it's going to print out the keys. And print them out in order. So it does maintain an that order. It's just I don't know the particulars of how it's implemented. I try to keep the more theoretical, abstract knowledge because, you know, I swap between programming languages. So I'd have to look that up. But anyway, so in this case, we want to maintain order. Now, the reason being is, how do you convert from Arabic to Roman? Well, I was kind of doing that earlier, right? If I had, right, what I was saying is that to get 1999, I was going, okay, so what's 1,000? That's M. What's 1900? Sorry, what's 900? That's CM. What is 990? It's XC. What is 9? It's IX. So there's different ways to do that. Now notice that what they've got over here is that they've got 1,900, 500, and 400. So basically they've got the ones where you're going to be subtracting 1 from the previous, 1 unit's worth from the or 1 power's worth from the previous amount. So here, or 1 base 10 from the previous amount. So 900, 500, 400, 100. So you'll need 90, 50, 40. So you'll need 90, 50, 40, and then the rest. But you don't need to subtract, but you don't need to put in 1, 2, 3, 4, or 5. You don't need to put in all possible combinations. So what about 8? How would I convert 8? Well, there'd be no need to, because I would see a 5 and then I'd see a 3. Sorry, well, how would I convert 8? Actually, I would need to, because, so how do I do 8? I would subtract 5 from it and make that into 3. And then from the 3s, I would subtract 1. So it would be a bit trickier, but it's possible to do it. So let's go ahead and take a look at how to do. So go ahead and try to do this one. So let's go ahead and fill in our remaining entries. 90, 50, 40, 10. X, X, L, L, and then XC, right? Yeah. And then we needed, what else? We needed nine, which is XI. And then we've got, that's 11. IX. And we need 5, which is V. 4, which is IV. Okay, so there's our dictionary. Okay, so there's our dictionary. So how would I do this? Actually, it's fairly simple. I don't have to go digit by digit. It's actually fair. It's actually, now that I think about it, fairly simple. So say I want to, so let's go ahead and talk about it, and then I'll leave it to you to do. So def convert Arabic. And what you're going to want to do is, obviously your Roman numerals are going to need to be a string, right? Okay. And what you're going to want to do is, while the Arabic, go through each of these numbers. And while you can subtract the number, this number, while you can subtract this number from the Arabic number, subtract it from the Arabic number. And what I mean by that is, so say that you've got 1900, right? So while I can subtract 1000 and keep it above zero, I'm going to subtract 1000, add an M here, and it'll stay above 0. And then that'll become 900. Now I can't subtract 1000 from 900 and keep it above 0. So I'm going to move on to the next 100. So the next number. Can I subtract 900? Yes, I can. And so on and so forth. So work on that. And we'll come back and see, and then we'll end class. To get the shared code, you need to refresh the page and then load the history. Like so. So refresh the page and hit load history. Three, I believe, covers file reading through file reading. I think. Generally, what it's covered, the chapter. So the chapter for quizzes, the chapter that it's posted in, sorry, the module that it's posted in, it covers the content up through that point.
That quiz is due tomorrow night, right? Before midnight.
Sorry.
When is that quiz due again?
Um,
The 13th, I believe.
Yep, you can check here under assignments. Let's do the 13th, and then I'll post the next quiz, which I think just goes up through file reading.
Cool.
There should have been a convert, but let's see. I don't think I saved it before I shared it. That was the issue. So let's go ahead and write that. So def convert Arabic to Roman. All right. Convert Arabic to Roman and return Roman. Oh, I shouldn't call it Roman though, because this is called Roman. And put in and make a mistake. That would be a bit of a pain. Output is equal to blank. So for val in Roman, which will be 1,900, 500, 400, 100. If while val is greater than or equal to the Arabic number, subtract that value from the Arabic number. And our output will gain what it's lost. Is that it? I don't know. Let's see. Print convert 1999. Oh. Looks like I did an infinite loop, so no. For each value in Roman. if the value is greater than that amount, let's go ahead and grab it out of the browser so that I don't accidentally freeze it up anymore. Oops. Let's go ahead and make sure that I'm here so that I'm not going to freeze it up anymore. Desktop, Rome. Okay, so now let's go ahead and print Arabic, comma, output. Save, run. Let's see what horrible thing I've done. No, it wasn't an infinite loop. It just didn't do anything. Oh, that's frustrating. Okay, so while, oh, duh. While the value I'm trying to subtract is less than the amount that's left. Right, so the first thing I did was I subtracted 1,000. Yep, so print val. There we go. What we got is that we started with 1,999. We've got removed 1,000 from that, so we got an M. Then we removed 900 from that, we got CM. Then we removed 9 from that. So now let's go ahead and see how that works for, say, something like 19. Let's go ahead and see how that works for 48. Actually, 78. So 78, what we're going to do is that we subtract 50 from that to get L. Then we subtract 10 from that to get X. Then we subtract another 10 from that to get LXX. And we have 8 left. So then we subtract 5 from that to get that value. And then we subtract the last 3 values to get our III. So our output is LXXVIII. Copy. Load history. Load history. Save and run. Share code. All right, so it is 3:18.